condensation and with evaporation. So let's look at this little experiment here. It's a closed chamber, and let's pretend that at the beginning we have only liquid water present. There's no gaseous water vapor present initially. So that means our vapor pressure here, as indicated on the little gauge, is 0. That's our initial state. But as we go on, we have water beginning to evaporate into water vapor, and we start to get a collection of water vapor molecules in the air over the water. The evaporation is occurring at a rate that is set primarily by the temperature of the water. So evaporation and temperature are tied together. As we get those water vapor molecules over the water, some begin to condense back into liquid water. And the rate of that condensation depends on the amount of water vapor molecules that are present. So as time goes on and we get more and more water vapor present over the water and our vapor pressure increases, our condensation rate continues to increase until it equals the evaporation rate. And when that happens, the vapor pressure is equal to the equilibrium vapor pressure. The condensation rate is equal to the evaporation rate. That's the state of equilibrium, when all those things are equal. And when that happens, the relative humidity is equal to 100%. And I think it's important to realize that condensation and evaporation are going on around you at all times. You just can't see them all the time because they're not visible at the individual molecular level, but they're occurring all the time. So let's wrap this up with a few key ideas that I want you to be able to tie together. First, vapor pressure depends on the number of water vapor molecules present, and that is connected to condensation rates and dew points. Dew point is the meteorological variable that we measure that is tied to the ideas of vapor pressure and condensation rates. Equilibrium vapor pressure, on the other hand, that depends on temperature, which is connected to evaporation rates. So you want to tie those ideas together in your mind. Relative humidity depends on both the vapor pressure and the equilibrium vapor pressure. So in other words, it depends on both dew point and temperature. So that means that relative humidity is actually not a good indicator of the amount of water vapor present because it depends on temperature. Relative humidity just indicates how close the rates of condensation and evaporation are to each other, or alternatively, the vapor pressure and the equilibrium vapor pressure, how close the dew point is to the temperature. Simply by increasing the temperature, you increase evaporation rates and the equilibrium vapor pressure, and that would act to decrease relative